Hello friends, welcome to VK lectures. In this lecture we are discussing the last part of the Karnataka Set 2020 question papers solving session, that is from question number 81 to 100. Maitland energy is calculated in. Now what is Maitland energy? Maitland energy is nothing but the electrostatic energy. This is the electrostatic energy. That is the Maitland energy. We are describing it as the electrostatic energy between the ionic uh, ions, between the ions in an ionic crystal. So this is about ionic crystal. So it's cohesive uh, energy, that means the attractive energy of the ionic crystal is due to electrostatic energy, that is the Maitland energy. Now Maitland constant allows for the calculation of the electrostatic potential, that is Vi, of all ions in the lattice felt by the ion at the position Ri. Now what does this mean? Now assume that this is the crystal and I am going to calculate the Maitland constant or Maitland energy for the ith particle, that is this is the ith particle. Now all these are J. Okay, all these ions are J. I am assuming this is of a positive and all J's are of negative. Now what is this Maitland constant or Maitland energy? It is the potential of this particular ion, that is the positive ion at the center, due to all these ions or charged particle in electrostatic. When we can say this is sum of all the electrostatic energy or the potential due to the neighboring ions. So in this formula Vi is equal to E by 4 pi epsilon naught sum over Zj divided by Rij, where J not equal to I. And what is Rij? Rij is the distance between, this is Rij for the first term or the first particle interaction. This is second Rij. Similarly all. Okay, so Maitland energy is for calculating the energy for ionic crystals. The total potential energy of the pair of inert gas atoms at separation R is given by V of R is equal to minus A by R power 6 plus B by R power 12, where A and B are positive constants. The question asked is, what is the repulsive force between the two atoms? Now what we know is the force F is equal to minus dou V by dou R. So we have the potential, that is, let me write dou by dou R of what is V? V is minus A by R power 6 plus B divided by R power 12. Now let's differentiate this. That's equal to minus of the first derivative of minus A by R power 6 is minus 6 with the minus sign into A divided by R power 7 minus 12B divided by R power 13. Okay, now just give this negative sign inside. This becomes minus 6A by R power 7 plus 12B divided by R power 13. Now for a force, if it is positive, we say that it is repulsive force. Repulsive force. If it is positive, we say that it is repulsive force, and if it is negative, we say that it is attractive force. Okay. Now in this force, the equation that we have got, the negative sign, this is the attractive force and this is the repulsive force. Now the question they have asked is the find the repulsive force. So the repulsive force F R is equal to, is this R represent the repulsive is equal to 12b divided by R power 13. If the question was asked what is the F attractive, the answer would have been the minus 6a divided by R power 7. But according to this question, the question asked is repulsive force. So your option is option B. In a crystalline solid with n number of unit cells, the number of allowed independent phonon modes of a branch is. Now, crystal vibration you can classify as acoustic and optical vibrations. These are frequencies, acoustic frequency and optical frequency. It represent lower, this is lower frequency and this is higher frequency. Okay, now in one dimension, if there are n atoms, then total number of phonon vibration will be equal to n, where again you can classify the n vibrations, few of them will be optical and others will be acoustic. There is only one acoustic and n minus 1 optical frequencies. This is for one dimension. Now for two dimension, so this is number of vibrations, phonon modes, you can write phonon modes n. For 2D there will be 2n phonon modes or phonon vibration. Out of that, 2 will be acoustic and 2n minus 2 will be optical. Similarly for 3 dimension, if there are n particles or n atoms, there will be 3n modes of vibration, out of which 3 will be acoustic, while 3n minus 3 will be, what is left in 3n, that will be optical vibration. So according to this question, this it is not sure in which dimension is unknown. Dimension is a question mark. If it is one dimension, there will be n number of phonon modes. If it is two dimension, there will be 2n number of phonon modes. Okay, this is the question. Number of phonon modes is the question. So please remember, in one dimension n phonon nodes, one is acoustic, n minus 1 is optical. In two dimension there will be 2n. This n atoms remain constant. So for two dimension there are 2n modes of vibration, while 2 is for acoustic, 2n minus 2 is for optical. Similarly for 3 dimension, 3n modes of vibrations will be there, phonon vibrations, in which 3 modes of vibration will be acoustic and 3n minus 3 will be optical vibrations. Heat capacity Cv of a metal is measured as a function of temperature in low temperature region. Assume that measured Cv is due to both electrons and lattice. Then plot of Cv versus T. Sorry, Cv by T versus T. So you have Cv is proportional to T cube. For metals we have, for metals, alpha T cube plus gamma T. This is what it is. Now what the question is, you have to find out Cv by T. Cv by T will be equal to alpha T square plus gamma. Now you have to plot a graph with the Cv by T on y-axis and T on x-axis. So Cv by T is proportional to alpha T square, so it is proportional to T squared. So T square and T, so you will get a curve in this way. But according to the option, linear in T squared means you have Cv by T on y-axis and x-axis you have T square. Then you get a linear graph. Cv by T here is proportional to T square. So T square and T square on x-axis and y-axis, if you have T square, you get a straight line. So this is linear in T squared. If this was the question, Cv by T and T along x-axis and Cv by T along y-axis, this is the graph. Okay, so you can keep it linear in T square. In metals A and B, electron densities are Na and Nb respectively. Their respective Fermi wave vectors are kFa and kFb. Then that means if kFa equal to 2 times kFb, then which of the following is true? Now since this is metal, that means metals, you can C of electrons are there, C of electrons, so we can consider it as a gas of electron or electron gas. Alright, electron gas, which is in 3 dimension. For 3 dimension, your wave vector or Fermi wave vector is proportional to n3 whole to the power 1 by 3, where 3 represent the dimension. If it was 2D, kf2 is proportional to n2 whole to the power 1 by 2. If it was 1 dimension, wave vector is proportional to n1 whole to the power 1. Okay, since it is 3D, your Fermi wave vector is proportional to n power 1 by 3, where n is electron density. Now let us take the question. kFa by kFb is equal to 2, which is proportional to what? N to the power 1 by 3. So we can write Na by Nb whole to the power 1 by 3. Now just take these two equations, that is 2 equal to Na by Nb whole to the power 1 by 3. So which means Na by Nb is equal to 2 to the power 3, which means Na equal to 8 times Nb. So 8 times Nb, your answer is option D. Now this is true only if we are talking about 3D, and since it is metal, it belongs to 3D. Okay, so please remember this formula from this question. Kf proportional to nd whole to the power 1 by d, where d is the dimension. In which dimension you are talking about? Dimension of, okay. A metal wire of radius r and electron density n is carrying a current I. Then the drift velocity Vd of the electron in the wire. Now drift velocity Vd is given by I divided by NEA, where A is the cross sectional area. So cross sectional area means pi r squared. So I divided by NE pi r squared. So your option is B. Now what is Vd? Vd is the average velocity. Average velocity with which electrons move when electric field E is applied. Okay. Now this question you can also use dimensional analysis. Dimensional analysis to get into the correct option. Now how? You check the first of it. Now what you need Vd. Vd means drift velocity, which is a unit of velocity. So meter per second. This is what you need. Now each option should give you meter per second, otherwise that is not wrong. That is wrong. So let us take the first option, that is I. I means charge per second. Charge per second. Pi, as it is you can write, no need. So r square is nothing but meter squared divided by n is number per meter cube into charge cube. Now this is not equal to meter per second. So charge and charge get cancelled, but this meter cube will go to the numerator and will become meter power 5. Okay, so you cross out your option A. Now check the option C. You get Q by second. N is, as I told, number per meter cube. E is nothing but the charge again, and pi you can leave, r square is meter square. Still this is not equal to meter per second. Now check out the fourth option. So you can cancel out option C. Now option D you can check. I is Q by second into 1 by r is nothing but 1 by meter. N is nothing but number per meter cube. Okay. E is nothing but the charge. Now let us see what is it is. Q and Q gets cancelled. Second remain m and m cube, m square remains. So m square divided by second. So this is also not equal to meter per second. So you can cancel out option D. So your option B is correct. If you want, you can check out that one also. I is nothing but Q by second. 1 by r square is 1 by meter squared. N is nothing but number per meter cube into 1 by charge Q. Q get cancelled, meter square and meter square get cancelled, meter remains, which is equal to meter per second. So your option B. So this is how you can get into the answer even without knowing the actual formula. So please try to use dimensional formula whenever you are not able to get anything out of the question. Application of Hall effect R. So before going into this question, application of Hall effect, let us understand what is Hall effect. Now this is your Z axis, this is your X axis, and this is your Y axis. Now here you have a metal or any object, you can say. Now you have applied a potential such that the electrons are moving in this direction. Electrons are moving in this direction and your current will be in opposite direction. And a magnetic field is applied along the z-axis. Magnetic field is along the z-axis. Now according to your left hand thumb rule, these electrons will be deflected downwards due to the force F is equal to Q into V cross B. And since V and B are in different directions, V is along x-axis and B is along z-axis, your force is along y-axis, right? Or the you have an electron moving in the y-axis, that means towards the y-axis. Now we know that the electrons will be placed here, right? All electrons are in the bottom part. Now due to which your positive charges will be, if it is a metal, positive charges due to induction, positive charges will be on the upper surface. So there is a potential developed. This is positively charged plate, this is negatively charged plate. There is an electric field developed. Electric field in which direction? Electric field in the negative y direction. So EY is given by minus Jx Bz by Ne. This is the value of the electric field developed. This development of electric field is proportional to Jx, where Jx is the current density. And Bz is the applied field, magnetic field B. N is the charge density, and E is the charge of the electron, or you can write Q if you are not sure about what charge. Now if this can be found out, now you see which all the quantities we can find. You can find out the magnetic field, you can find the type of the charge, you can also find density of the charge. This is type of the charge and this is density of the charge. So it can be used to find out the charge carriers, type of the charge carriers, density of the charge, and unknown magnetic field. So all the three given options are correct. So what is the code? Code is A1, 2 and 3 are true. Which of the following is not true? A superconductor is characterized by. Now superconductor, option A is persistent current. Now the idea of superconductor is arising only because of its conductivity. Its superpower to conductivity of electrons. So the conductivity of electron means existence of current. So option A is true. Now perfect diamagnetism. The magnetic field inside the superconductor is equal to 0. This is always true. But depends on temperature. Existence of energy gap. So this is B also true. Now existence of energy gap. This energy gap does not mean the gap between the energy levels. It means to break Cooper pair. Cooper pair is responsible for conductivity, scattering of phonons. That energy required is nothing but the energy gap. So this is also true with respect to superconductor. Now heat capacity, there is no relation, no specific relation we have to say. At some temperature it behaves linearly, but not always. No specific relation with the temperature. for CV, specific heat capacity. Okay, so your option is D, which is not true. Given below are two lists of statements. Match the items in list 1 with those in list 2. First one is point defect. Point defect, it increases with increase in temperature. Just remember the case of your semiconductors. Okay. Now superfluidity. Superfluidity is a phenomena, and this is an effect. Fountain effect. This effect is due to superfluidity. What do you mean by superfluidity? Or superfluidity means there is no viscosity. That means the fluid will flow indefinitely. If you stir this superfluid liquid, it will be keep rotating indefinitely. This is what is meant by superfluidity. Now liquid crystals. Liquid crystals have orientational order. Insulators, high energy gap. Now Meissner effect is related to superconductivity. Superconductivity. So superconductors. So you can check the option 1 belongs to 3, 1 all the 3, okay, and 2 belongs to 2, 1, 3, 2, 2. So option D. Now let us write down this equation here. Muon plus electron plus, that is positron, plus electron neutrino. Now let us see what about the charge. Charge here there is 1, that is positive 1 plus. This is again 1 plus. This again electron neutrino, the charge is 0. So charge is conserved. Plus 1 on the right side, plus 1 on the left side. Now about lepton number of electron. On the right hand side there is no electron particle, so 0. Electron plus, that is E plus, what is the lepton number? Minus 1. Electron neutrino plus 1. So this is conserved. Lepton number is conserved for electron. Now for muon. Muon plus. So this is electron number minus 1 changing to on right side you don't have any muon. So 0, 0. So this is not conserved. Lepton number for muon is not conserved. Now isospin. All are not an isospin particle. Their isospin is 0, so it is conserved. Now what we left with baryon. Now since all are leptons particle, the baryon number on right side and on the left side is 0. So this is also conserved. So what is not conserved? Lepton number for mu. So lepton number is not conserved. Half-life of a radioactive sample is 20 days. This means that now if there are 100 radioactive atoms, so 100 atoms, these are radioactive. Now after 20 days it will become 50. This 100 atoms will become 50. This is what is meant by half-life. After 20 days it will become half. Again after 20 days it again will become half of what is left, so that will become 25. This goes on. So radioactive is omnipresent. That means it is all over, and it will not get decayed. It will not become zero, because if you keep dividing it, it won't become zero. You won't get a value 0. It will be very near to 0, but you won't get a value near 0. So so you got an idea what is about it. Now, how many half-lives are there? N is equal to number of half-life. Okay. Now, after n number of half-life, how much of the particle or how much of the radioactive element is left is given by, if n is the initial number, or you can write n naught, divided by 2 to the power n, where n is number of half-life. So here they are telling substance completely disintegrates after 40 days. No complete disintegration takes place. Substance completely disintegrates after 80 days. Here also completely disintegrates doesn't happen. 1 by 8 part of the substance disintegrate. 1 by 8 part of substance disintegrate means what? Let us see. In 60 days. 60 days means if you divide it by the half-life, you will get 3 half-lives. So n is equal to 3. Just substitute here n naught divided by 2 to the power 3. So that is 1 by 8 of n naught. 1 by 8 of n naught, that it is left. What is left? After n half-life, what is left is n naught by 8. It is not 1 by 8 of substance disintegrates. What is that? 7 by 8 will get disintegrated and 1 by 8 will remain. 7 by 8 of the initial number will get disintegrated and 1 by 8 will remain. So option D, 7 by 8 part of the substance disintegrates in 60 days. That means 60 days means 3 half-life. The decay of proton to positron and gamma. Now, since there is a presence of gamma, it can be a electromagnetic interaction. This is just our intuition. Now, let us understand. For any interaction to happen, charge, lepton number and baryon number must be conserved. These are called primary quantum number. Primary quantum number. Okay. So, if any one is not conserved, either Q, L or B is not conserved, then interaction is forbidden. That is not allowed. Interaction is forbidden. Not allowed. It's not possible. So for any basic interaction, Q, L and B numbers must be conserved. Alright. Now let us take the interaction. Proton changing into positron plus gamma. Let us see about charge. Proton charge is +1. Electron, that is positron charge is again +1. Gamma does not have charge. So Q is conserved. Charge is conserved. Now you have a lepton here. Let us take lepton. Lepton number for electron. Proton is not a lepton number, so 0. Here positron have a lepton number -1. Gamma does not have a lepton number, so this is not conserved. Similarly, you take for baryon number. Proton is a baryon, so you have +1. Positron is not a baryon, 0. Again, gamma does not have a baryon number, so this is also not conserved. So L and B not conserved, only charge is conserved. So this is not allowed. The interaction is not allowed. So your answer is B. The function of a moderator in nuclear reactor. Now, what happens here? Once the first fission occurs, there will be about 2 to 3 neutrons. These neutrons will be of high energy. But these high energy neutrons are not efficient. So we have to bring it to the thermal energy. So they are called thermal neutrons to reduce the energy so that collision occurs with the fissile material. Collision occurs with the fissile material effectively. Okay. Fissile material, you can talk about uranium-235. Okay. So this has to be done. So this process is done using moderator. Now your option B is the correct one. Now look at this option A, to absorb unwanted neutrons. This unwanted neutrons is being absorbed by graphite, carbon. Okay, carbon rod. We are using carbon rod for absorbing this unwanted neutrons. Okay, so here the option B is the correct answer. Quark contents of delta plus and proton. Now proton you already know, U and D. Up has 1 by 3 plus charge, sorry 2 by 3 plus, again 2 by 3 plus, down quark is having minus 1 by 3 charge. So together you will get plus 1 as the charge. So proton is plus positive charge. So U and D. Now what here given is, it is spin 3 by 2 baryon quark structure. Okay, so spin 3 by 2 baryon quark structure you have. This is represented in decuplet. Okay, now it starts from delta double plus and ends in delta minus in the first row. And here you have sigma plus, sigma naught, sigma minus, cascade naught, cascade minus, and omega minus. And the corresponding quark structure is given here towards the left. It starts from triple U. That means delta plus plus or double plus is having U as the quark structure. Delta plus is having UUD. Delta naught UDD, and it goes. So corresponding to each particle. So this is all particle arranged in this decuplet. 10 particles are there. Spin 3 by 2. How many particles? 10 particles arranged in decuplet. Now spin 1 by 2 baryon. It is arranged in octet. Okay. Alright. Now you can see omega minus is triple S. All are strange particles. Okay, and your question needs delta plus. Delta plus is having UU and D. So both proton and delta plus is having same quark structure. So your option C is the answer. S indicates strange particle, D is down, and U is up quark. So this is up quark, this is down quark, and this is strange quark. Okay, that's it. Now the middle one, that is in the center, you see the combination of all the three, U, D and S. That is having zero charge. Number of S indicates the strangeness of that particle. For example, I want to find out the strangeness of sigma plus hyperon. I want to find out its strangeness. Now immediately go to its position in the quark structure. So SUU, how many S are there? 1. So strangeness is equal to -1. When you come down to the next level, for cascade naught and cascade minus, there are 2 S, which means strangeness is equal to -2. Okay, for this omega minus, how many strange particles are there? 3. So this is omega minus is having 3 strange particles. So S is equal to minus. The ground state of a deuteron is an admixture of the following state. Now, uh, deuteron is deuteron is the a group of proton and neutron. Now this proton and neutron both are spin half particles, so the spin value is equal to 1, and for neutron value also spin value equal to spin is half, and for proton and neutron, so the net spin is equal to 1. Now according to the wave function of the deuteron, we have psi is equal to the AS, that is the coefficient of the AS state, the wave function at L equal to 0, plus a d at the wave function psi at L is equal to 2. Now at L equal to 0 and L equal to 2, these are the two states. Now this is L equal to 0 represent the S state, while L equal to 2 represent the D state. Now since the spin is equal to 1, it gives 2s plus 1, so let us write down 2s plus 1 is equal to 2 into 1 plus 1, so that's equal to 3. Now for both S and D, we have the triplet state, now going back to the option, we have the only option that gives the triplet state are this option C, which gives the triplet state of S and triplet state of D. So the option is option D. So how you write the state is L, J and 2S plus 1. So the first one is L equal to 0, so you can write S, J value is 1, and this is a triplet. Now for the second one, D, you have the triplet state 3 and corresponding values of J are 1, 2 and 3, either of this. So according to the options, you have 3s1 and 3d1 as the admixture of the state. Now how many percentage, what is the percentage of yes is around 96 percentage, and D state, that means the particle or the deuterons in ground state has a probability, that means it is in ground state at S, that is 96 percentage, and only 4 percentage it is in the D state. This also you can remember as part of this question. The energy dependence of the cross section of a reaction between two particles close to the resonance energy E is described by. Now let us see the options one by one. First is the Bethe-Bloch formula. Bethe-Bloch formula is describes the mean energy loss per distance traveled by charged particle in any matter. Now this charged particle can be either proton, alpha particle or any ions. Now it is also called the stopping power of the material for a certain charged particle. Now the option 2, which is the Breit-Wegner formula. Breit-Wegner formula describes the resonance in neutron cross section in terms of energy. On the left hand side, what you are seeing is the Breit-Wegner formula uh, for the cross section. This k divided by e square minus m square whole square plus m square gamma square, where E is the center of mass energy that produces the resonance, m is the mass of the resonance, gamma is the resonance width or decay width related to its mean lifetime according to tau equal to 1 by gamma. Now the option C is Gamow-Teller formula. This is a selection rule, or you can also say it as a Gamow-Teller rule used for beta decay for the transition involving no parity change. There is no parity change for the transition. The option D is Weizsäcker formula. Weizsäcker formula is an empirical formula used for finding out the binding energy of the nuclei for in a liquid drop model. It's an empirical formula for liquid drop model. Now, according to what we have discussed about all four options, the option that satisfies the question is option B. Mass defect of an atom divided by its mass number. Now, what is this mass defect? Mass defect is nothing but the isotopic mass minus the mass number divided by the mass number. That is nothing but our packing fraction. Now this packing fraction can have 0, -1 or +1. These are the possibilities. 0 means this is monoisotopic. There is no other element. There is isotope present. So that is indicated by 0. Now -1 means there is reduction in mass. So binding energy is present. They are stable. Okay. Now +1 indicate they undergo fission and fusion. They are unstable. For fission we have uranium-235. For fusion we have H11. Alright. So here our answer to this question is packing fraction. Mass defect divided by the mass number. Packing fraction. For deuteron, packing fraction is nothing but binding energy. This is what the question is. Now what is deuteron? Deuteron is nothing but hydrogen plus 1 neutron. You add neutron to the hydrogen atom, you get deuteron. Okay, so that's it. Now you want the neutron mass. Neutron mass is given this much, 2.014102 mu. Now you want mass defect, delta m. Delta m is equal to hydrogen atom mass of the hydrogen atom plus mass of the neutron minus the mass of deuteron. Now the values are given, you can just add it up. 1.007825 plus 1.008665 minus the mass of neutron. Neutron is this, mass of the deuteron. Deuteron is 2.014102. Now this sum is equal to 2.0164 9 minus 2.01410. What you get is 0.0002388. Now this is delta M. Now what you want energy? Delta M into 931.5 million electron volt. So that's equal to, what you're getting is 2.224422 million electron volt. Now this is for two nucleons, right? Two nucleons are there. This hydrogen atom plus one neutron. Hydrogen atom is having a proton and one neutron. So these two are two nucleons. So if you divide by 2, what you're getting is 1.1122 million electron volt per nucleon. So your answer is option C. Radius of a nuclei whose mass number is 216. Now how to find radius? Radius is equal to R naught into a to the power 1 by 3, where a is the mass number. Now we want to find out R. R is equal to, R naught value is given as 1.2 into 10 to the power minus 15 meter. A value is given as 216, a power 1 by 3. So that's equal to 1.2 into 10 to the power minus 15 meter. This cube root of 216 is nothing but 6. That's equal to 7.2 into 10 to the power minus 15 meter. So your answer is option A. So please remember this value from this question. Equation R is equal to R naught at power 1 by 3. And we are into the 100th question. The question is, for the magnetic multipole transition, the parity is. Now let us understand what is this parity for. This parity we are discussing is about gamma transition. Gamma transition, we need parity. And what is parity? Pi is equal to minus 1 whole to the power L. This is the total angular momentum, L. Okay, L value for the particular state. Now for the parity pi, this is given by initial parity times the final parity. Now the parity can be either odd or even. So this is an even parity, and here we have the odd parity. Okay, now for even parity, the electric multipole transition E will be even. Okay, and because electric multipole transition will remain same, so E even as, let me write E equal to E1, and the magnetic multipole transition M is odd, because E will remain same and M will change, that is magnetic multipole transition will change. Now when we coming to the odd parity, here also the electric multipole transition will remain same, so E parity is odd, while the M, the magnetic multipole transition is even. Okay, now look at the question now. For the magnetic multipole transition, so this is what we need, M and M. So this M equal to odd when parity is even, right? Odd for even parity, and here you have M equal to even for odd parity, right? So odd for even L is parity. That means pi is equal to minus 1 whole to the power L. Now if L equal to odd, we have pi equal to odd. If L equal to even, pi, the parity will be equal to even. Okay, so odd for even pi and even for odd pi. Fine. So the option is option A.